If you go into outer space without protection, you'll die. The lack of pressure would force the air in your lungs to rush out. Gases dissolved in your body fluids would expand, pushing the skin apart and forcing it to inflate like a balloon. Your eardrums and capillaries would rupture, and your blood would start to bubble and boil. Even if you survived all that, ionizing radiation would rip apart the DNA in your cells. Mercifully, you would be unconscious in 15 seconds. But one group of animals can survive this, tiny creatures called tardigrades. Hello and welcome to Knowledge TV Facts. We will talk about the most resilient and amazing tiny animal with superpower ability. The tardigrade, with the size about 1 millimeter long. The tardigrades were discovered in 1773 by a German pastor named Johann August Ephraim Goes. 3 years later, the Italian clergyman and scientist Lazzaro Spallanzani discovered that they had superpowers. Spallanzani added water to sediment from a rain gutter, and looked under a microscope. He found hundreds of little bear-shaped creatures swimming around. In his book, Opuscoli di Fisica Animale, e Vegetable, he named them, Il Tardigrado, meaning, slow stepper, because they moved so slowly. Tardigrades, at first glance, are intimidating. They have podgy faces with folds of flesh, a bit like a Doctor Who monster. They have 8 legs, with ferocious claws resembling those of great bears. Their mouth is also a serious weapon, with dagger-like teeth that can spear prey. In 2007, thousands of tardigrades were attached to a satellite and blasted into space. After the satellite had returned to Earth, scientists examined them and found that many of them had survived. Some of the females had even laid eggs in space, and the newly hatched young were healthy. It's not just the harsh environs of outer space that tardigrades can survive in. The little critters seem adept at living in some of the harshest regions of Earth. They have been discovered 5,546 meters, 18,196 feet, up a mountain in the Himalayas, in Japanese hot springs, at the bottom of the ocean and in Antarctica. They can withstand huge amounts of radiation, being heated to 150 degrees Celsius, and being frozen almost to absolute zero. How do these seemingly insignificant creatures survive in such extreme conditions, and why have they evolved these superpowers? It turns out that tardigrades have a host of tricks up their sleeves, which would put most organisms to shame. But there's no need to worry. Tardigrades are one of nature's smallest animals. They are never more than 1.5 millimeters long, and can only be seen with a microscope. They are commonly known as water bears. There are 900 known species. Most feed by sucking the juices from moss, lichens and algae. Others are carnivores, and can even prey on other tardigrades. They are truly ancient. Fossils of tardigrades have been dated to the Cambrian period over 500 million years ago, when the first complex animals were evolving. And ever since they were discovered, it has been clear that they are special. In truth, this wasn't a first. Back in 1702, the Dutch scientist Anton van Leeuwenhoek sent a letter to the Royal Society in London, entitled, On Certain Animalcules Found in the Sediment in Gutters on the Roofs of Houses. He took dry, apparently lifeless dust from a gutter and added water. Using a microscope of his own devising, Leeuwenhoek found that within an hour many small animalcules became active, and began swimming and crawling around. These animals were rotifers, tiny aquatic creatures that look like they have wheels on their heads. They could seemingly survive months without water. However, tardigrades may be able to survive without it for decades. In 1948, the Italian zoologist Tina Franceschi claimed that tardigrades found in dried moss from museum samples over 120 years old could be reanimated. After rehydrating a tardigrade, she observed one of its front legs moving. This finding has never been replicated. But it does not seem impossible. In 1995, dried tardigrades were brought back to life after 8 years. For most animals, life without water is completely impossible. When a typical cell dries out, its membranes rupture and leak, and its proteins unfold and aggregate together, making them useless, says extremophile researcher Thomas Boothby of the University of North Carolina in Chapel Hill. DNA will also start to fragment the longer it is dry. Somehow tardigrades avoid all this. Since water bears can survive drying, they must have tricks for preventing or fixing the damage that cells like ours would die from. How do they do it? One of the key discoveries came in 1922, courtesy of a German scientist named H. Bowman. He found that when a tardigrade dries out, it retracts its head and its 8 legs. It then enters a deep state of suspended animation that closely resembles death. Shedding almost all the water in its body, the tardigrade curls up into a dry husk. Bowman called this a tonsion form, but it is now commonly known as a ton. Its metabolism slows to 0.01% of the normal rate. It can stay in this state for decades, only reanimating when it comes into contact with water. When tardigrades start to dry out, they seem to make a lot of antioxidants. These are chemicals, like vitamins C and E, that soak up dangerously reactive chemicals. This may mop up harmful chemicals in the tardigrade cells. Tardigrades face a particular threat from reactive oxygen species. These substances are produced as byproducts of normal cell function, but can break down the main components of a cell, including its DNA. Animals exposed to environmental stress often have lots of them floating around. The antioxidants may explain one of tardigrade's neatest abilities. If a tardigrade stays in its dry ton state for a long time, its DNA gets damaged. But after it reawakens, it is able to quickly fix it. It's clear that the ton state is key to tardigrade's ability to cope with being dried out. But long before Bowman discovered it, tardigrades had revealed other superpowers. For starters, they seem not to care what temperature it is. In 1842, a French scientist named Doyer showed that a tardigrade in its ton state could survive being heated to temperatures of 125 degrees Celsius for several minutes. In the 1920s, a Benedictine friar named Gilbert Franz Röhm brought tardigrades back to life after heating them to 151 degrees Celsius for 15 minutes. Röhm also tested them in the cold. He immersed them in liquid air at -200 degrees Celsius for 21 months, in liquid nitrogen at -253 degrees Celsius for 26 hours, and in liquid helium at -272 degrees Celsius for 8 hours. Afterwards, the tardigrades sprang back to life as soon as they came into contact with water. We now know that some tardigrades can tolerate being frozen to -272.8 degrees Celsius, just above absolute zero. To put that into perspective, the lowest temperature ever recorded on Earth was a balmy -89.2 degrees Celsius in central Antarctica in 1983. The tardigrades coped with a profound chill that does not occur naturally and must be created in the lab, at which atoms come to a virtual standstill. But while we have some idea of how tardigrades cope with the cold, we have no idea how they cope with heat. At scorching temperatures like 150 degrees Celsius, proteins and cell membranes should unravel, and the chemical reactions that sustain life cease to happen. The most heat-tolerant organisms known are bacteria that live around the edges of hydrothermal vents in the deep sea. They can still grow at 122 degrees Celsius. If Röhm is to be believed, tardigrades can survive even higher temperatures. Many animals that have evolved to live in hot places, like hot springs and scorching deserts, produce chemicals called heat shock proteins. These act as chaperones for proteins inside cells, helping them keep their shape. They also repair heat-damaged proteins. That's all well and good, but there is no conclusive evidence that tardigrades produce these chemicals. Factor in the other things they can survive, and the picture becomes even more baffling. In 1964, scientists exposed tardigrades to lethal doses of X-rays and found that they could survive. Later experiments showed they can also cope with excessive amounts of alpha, gamma and ultraviolet radiation, even if they're not in the ton state. Radiation was one of the biggest threats facing the tardigrades sent into space in 2007. Those exposed to higher levels of radiation fared worse than those protected, but the mortality rate was not 100%. They can also cope with extreme pressure that would squash most animals flat, according to a study published in 1998 by Kunihiro Seiki and Masato Toyoshima of Kanagawa University in Hiratsuka, Japan. They found that tardigrades in the ton state could survive a pressure of 600 megapascals. This is beyond anything they might encounter in nature. The deepest part of the sea is the Challenger Deep in the Mariana Trench in the Pacific Ocean, which goes down 10,994 meters. There, the water pressure is around 100 megapascals. Somehow the tardigrades survived 6 times that. At these crushing pressures, proteins and DNA are ripped apart. Cell membranes, which are composed of fat, become solid like butter in a fridge. Most microorganisms stop metabolizing at 30 megapascals, and bacteria can't survive much beyond 300 megapascals. Going into the ton state is a risky decision. There are probably several reasons why more animals and plants haven't evolved the tardigrade's abilities, says Boothby. Many animals probably just don't need to. They either don't live in environments that can quickly dry out, or they can develop ways of avoiding drying out, like the camel. But beyond that, there are surely costs to the tardigrade's abilities, costs that other animals have avoided paying. In particular, going into the ton state is a risky decision. When a tardigrade completely dries out, it becomes inactive and is unable to actively avoid dangers in its surroundings, says Boothby. An inactive tardigrade might not die of thirst, but it could get eaten. We know that a lot of desiccation-tolerant organisms have to make xenoprotectants, molecules that keep bacteria and fungi from basically eating them while they are in their inactive state. It may be that becoming as tough as a tardigrade wouldn't pay off for other animals. But it has worked for them. They are 500 million years old and live all over the planet, so they aren't going anywhere. Thank you so much for watching. If you like this video, please click the subscribe button.